Venn diagrams advanced. Now, just before we start, just want to remind you that there is a notes jotter available for this video. If you just check the description below, you can find a download link for it, so you can work along with me as we go through the video. Okay, so in our first example, we are told that 40 people are asked if they like hot drinks. 15 people like both tea and coffee. 25 people like coffee. 8 people don't like tea or coffee. One person is chosen at random. What is the probability that they only like tea? Now, before we get going with this, I just want to point out how I'm looking at this and thinking this is a Venn diagram question. First of all, is actually the way that the question is set out. We've got a total number of people, and then we have some information about those people split into different categories. And the key one for me here is actually the first line here. We've got information about where people both like something, so there is an intersection. That's a suggestion that we do require a Venn diagram for this question. So what we've got in this case is a two-circle Venn diagram, because we only have two categories. We have people who like tea and we have people who like coffee. Within this diagram though, we do need to label it, so we want a T for tea and a C for coffee. The box around the outside is an important feature because that is everybody who doesn't fit into the two categories of liking tea or coffee. They are important within this. When building the Venn diagram, the first place I would always be looking is where we've highlighted those people who like both, because that is going to be the intersecting point. And so this section in the middle of our diagram is the important piece. So we know that there are 15 people in that section, so we can tick that bit off. Now it says 25 people like coffee. Now the important thing here is that those 25 people include those that are in the centre, so we just need to do a quick subtraction. 25 take away 15 equals 10, so there will be 10 people in this section, and we can tick that section. It also says that 8 people don't like tea or coffee. Now those people must be out here on the outside, because they are not someone who does not like tea or coffee, so are not in any of the circles. The problem is we've got a little gap. We've got a gap in the tea circle, so we need to work out how many people are in the area that only like tea. And so for that, we need to think about the fact we had 40 people to begin with, and we've already dealt with 15, 10 and 8. So if we add those together, we'll get 33 people, and so the remainder must be the people who only like tea. 40 take away 33 is 7. Now the diagram is a good starting point, but the question was actually about a probability, so it's one person is chosen at random. Now, an important part here, because it is one person chosen at random, we've got no other information there, so we are dealing with the entire group, so all 40 people. And it is the probability that they only like tea, so it is actually that value we worked out at the very last point. We are dealing with the 7 people who only like tea. So our probability would therefore be 7 out of 40. And with probability, generally fractions are the best way to go, because they're the easiest way to actually answer the question, and it means that we can very quickly get a result. Now the second part of our question is what makes this an advanced question. It is this phrase at the front, given that. Given that the person likes coffee, what is the probability that they also like tea? Now the phrase given that means that we are limiting what we are actually looking at. We've been told that the person must like coffee. and therefore in our diagram we are now only interested in this section here, the people who like coffee. And so in that section we only now have 25 people, and so our probability is now going to be out of 25 rather than 40. Now the people who also like tea, well, that is the overlap, and so that is 15 people. Now it doesn't ask us to simplify here, but we really should. 15 out of 25, they're both multiples of 5, so we can divide by 5, 3 over 5. Okay, so our next example, out of 60 people surveyed, 24 had a cat, 39 had a dog, 11 had neither. Given that a person selected has a dog, find the probability that they also have a cat. Now again, in this question, it is another Venn diagram question, because in this case we have people separating themselves into people who have cats, people who have dogs, and people who have both or neither. So we have intersection between the two groups. Now it's going to look like this. Again, we've got our box around the outside for those people who don't like either. Let's begin though with labelling our two categories, cat and dog. And in this case, we haven't got any information about an intersection, so we can't begin in the centre. We're going to have to go down actually to the last line. 11 had neither, and so those 11 people must be on the outside of our diagram. Now, how do we decide what goes into the middle? Well, if we look at the two values we've got here, 24 and 39. Now 24 plus 39 is 63. Now there cannot be 63 people in our diagram because we only asked 60 people to begin with. And also we already know that 11 people don't have either type of pet. And so we need to deal with those 11 people. There were 60 people in total, and 11 don't have either, which means we are only left with 49 people who either have a cat or a dog. It's the two values that we've now just calculated which are the really important values, because what we need to know is how many people are in the intersection, how many people have both a cat and a dog, and that comes from the 63 people that we have put together. Take away the 49 people that we know are in the two circles altogether. And if we do that, we will get an answer of 14. Because they are the overlap, they are the intersection. And so we have 14 people in the middle. Now this helps us with filling in the rest of the diagram, because we knew 24 people had a cat. If 14 are in the intersection, then 10 must be just in the cat section, and if 39 people had a dog, then 39 take away 14 is 25. Now just to check, let's make sure that that does definitely add up to 60, as we should have 60 people in total. We have 11, 21, 35, 60. It does. We have 60 people in our diagram. Now comes the actual probability question. Given that, and there it is again, that key phrase, given that a person selected has a dog, find the probability that they also have a cat. And so, because we've been given that they have a dog, we're only interested in the right hand circle, in which case there are 39 people. And so our probability is going to be out of 39. How many of them also have a cat? Well, that takes us to the section A in the middle, the intersection between the two groups. That is 14 people. And so our probability will be 14 out of 39. Okay, so in the third example, we're now getting into the section that is really the higher GCSE versions of these questions. Lots of information and quite complicated ways of going around it. So we've got to take this very, very carefully. A year group of 120 students are making their GCSE option choices. They all choose at least one of history, media studies and PE. 50 students choose history, 19 students choose media studies and PE, 7 students choose all three, 39 students choose PE, 9 students choose history and media studies but not PE, and 18 students choose only PE. 2 students are chosen at random. Find the probability that one student chooses only history and the other chooses only media studies. Now, first of all, you'll notice here we have 3 different categories. We have history, media studies and PE. And so we're going to need 3 intersecting circles this time. And in this case, we know that the 120 students each choose at least one. So we don't actually need the box around the outside this time because there isn't going to be anybody outside of our categories. We have history, we have media studies, we have PE. Now, if we go down the list here, we can't straight away start writing in the numbers. We need to find somewhere to start. And for me, my favourite place to start is always right in the centre, the place where all 3 things intersect. And so that would mean somebody who took history, media and PE. And that information is given to us here. 7 students choose all 3. And so we can straight away fill in that 7 students must be in the centre. Now, what I want to now start thinking about are just going out a little bit further. Can I find any of the values around here where there is an intersection between 2 subjects? And if we look at the line above what we have in blue, we are told that 19 students choose media studies and PE. So the overlap between media studies and PE is 19 students. But that is 19 students that include the 7 who are in the centre. And so 19 take away 7 gives me 12. Can I find any more information that links together just 2 sections? Well, 9 students choose history and media studies, but not PE. So that means that they are choosing history and media studies but not PE, means that they are not in the intersection, they are just linking history and media studies. So there we have 9 students. We are told also a pretty straightforward piece of information, actually the very last line, that 18 students choose only PE. So we can add that piece of information. 18 students only choosing PE, they must be in the circle on their own. And the last piece of information there, if we just go to the 39 students who choose PE, well, let's have a look at how many students we currently have in the PE circle. We have 18 plus 12 is 30, plus 7 is 37, which means we have 2 people left who must have taken history and PE. Our last piece of information that we were given, 50 students choose history. So we need to find out how many people are in the final section for history. We have 9 students, plus 7 students, 16, plus 2 students, 18. So we actually have 32 students left over. The very final section, we've now included every piece of information we were given to start with, but we still don't know how many students only selected media studies. And so from now we need to take our 120 students in total. We know that this circle for history is 50, so we can already say this piece is 50. If we add the other two sections, we know 50, 62, 70, 80 to get us to here. And so the last section, we must have 40 students who only selected media studies to make the 120 in total. Now we come to the main part of the question. Two students are chosen at random. Find the probability that one student chooses only history and the other chooses only media studies. Now, what we need to think about here are, first of all, the individual probabilities. What is the probability that one student chooses only history? Well, if we have a look, that means we are dealing with these 32 people here, and so we are looking at 32 out of the 120 that we began with. But there's a little trick here within the question. Because we are choosing two people, we basically have to think we've chosen one first and then the other. And so the media studies people are these 40, and so we have 40 out of, but now we are not dealing with 120 people. We've already selected one of these history people, and so we now only have 119 people. And so the two probabilities we need to use are 32 out of 120 and 40 out of 119. The next little area is the fact we've got this word and suggests that we need to multiply. And so we would do 32 over 120 times 40 over 119. We're going to do that on a calculator. Type the two fractions in, multiplied, and you will be told the answer is 32 out of 357. That's the fully simplified version of the answer, and so that is the answer we want to give. Okay, and so now we come to the exam question. Now this came from Edexcel in June 2018. It's higher paper 3, so we are dealing with a calculator question here. 50 people were asked if they speak French or German or Spanish. Of these people, 31 speak French, 2 speak French, German and Spanish, 4 speak French and Spanish but not German, 7 speak German and Spanish, 8 do not speak any of the languages, and all 10 people who speak German speak at least one other language. 2 of the 50 people are chosen at random. Work out the probability that they both only speak Spanish. Now for this one, we have 3 different categories this time, French, German and Spanish, so we are going to need 3 circles. And also we do have a little bit of information that say that some people do not speak any of the languages, so we're going to need the box as well. Now we're going to have to begin by just labelling the diagram. So we're going to have French, and we're going to have German, and we're going to have Spanish. Now, as always, when we're filling in the diagram, what we want to begin with is, do we know the very centre of the diagram? Do we know an intersection of all 3? So, do we know how many people speak French and German and Spanish? And we do know that because it is given to us here to tell us that 2 people speak all 3. And so we'll fill that in to say that 2 people speak all 3. If we move to the next line down, we are told that 4 speak French and Spanish but not German. Now that means we are looking at the section which is French and Spanish here, but not German. So those 4 are going to be in that section there. In the next bit, we are told that 7 people speak German and Spanish. So German and Spanish is going to be this whole section. Now we've already used 2 of those people, and so we are only looking at 5 in that section. If we go to the next line, we have that 8 do not speak any of the languages, and that tells us that there will have to be 8 people on the outside. And the last little piece of information that we've got is coming from the bottom line. 10 people who speak, all 10 people who speak German speak at least one other language. Now the information that's given me is twofold. I'm being told that actually there is nobody in this section of just speaking German. It's also telling me that that whole circle has to add up to 10. So 5 plus 2 is 7, so the last section there must be 3. There is an extra piece of information in the very first line, that 31 people speak French. And so we need to work out how many people must be in this section here of only speaking French. Well, if we add up the other 3 elements, 3 plus 2 is 5, plus 4 is 9. So we need the remainder to get us up to 31, and that will be 22. And finally, the last little piece, we need to know how many people only speak Spanish. And if we're going to find out that information, we need to use the idea that we started with 50 people. So there are 50 people who were asked. 50 people who were asked. So if we take all of our values, we have the 31 people who speak French, the 5 who speak German and Spanish, so that's 36, plus the 8 who don't speak any at all. So that is up to 44, leaving just 6 people who speak only Spanish. Now that value is going to be very, very important, because now when it comes to the actual question, 2 of the 50 people are chosen at random. Work out the probability that they both only speak Spanish. So we need to begin with the first person that we select. The first person is going to be one of the 6 people, and it's 6 people out of 50. But again, like the previous example, this is a situation where we're choosing 2 people at once. So as soon as we've selected one person from that group, there are now only 5 people remaining in the group. And there were 50 people, one person has already been selected, so now we only have 49 people. And again, because this is 2 people both speaking, that is like me saying one person who speaks Spanish and another person, and that and creates a multiply. So we're going to multiply 6 over 50 times 5 over 49. And as I mentioned earlier, this is a calculator paper, and therefore we are going to use our calculator to multiply those 2 values together. And the answer that our calculator will give is 3 over 245.